Welcome to the foundation course. Today, our topic is about scalars and vectors. It is a mathematical tool used in physics and maths, as well as in other branches related to physics and also mathematics. What are scalars and vectors? Before moving on to what are scalars and vectors, we will consider a particular situation. Let's say that you are going to your school. So, what do you say when you reach school from home? You say that I have traveled, let's say, 10 kilometers from my home to the school. So, what you mention here is 10 kilometers, which is the magnitude or the numerical value of the distance traveled by you and also the direction, which is from home to your school. So, first of all, we will learn about what is a scalar. All those physical quantities which can be explained by a number magnitude or value with suitable units for their complete description are known as scalar quantities. For example, let me give you a situation where you need to measure, let's say, the length of your pencil. Okay. So, to measure it, you will use a scale with calibration in the centimeter unit. So let's say the length of your pencil is 6 centimeters. So this is the length of your pencil. Since a length of a body can be measured only by a number, it can be completely described by a number and its unit. It is known as a scalar quantity. Other examples are, let's say, mass, time, etc. For example, you have a certain mass. Obviously, every matter has mass, but it does not depend on what direction that body is going, right? So, mass is also scalar quantity. Also, time. Suppose you will need 1 hour to move from your home to your school. So, to mention the time 1 hour, you do not need any other parameter to describe it. So that is why time is also a scalar quantity. Now, we will be understanding about a very important concept called vector. What is a vector? A vector, all those physical quantities that need direction besides the numerical value or magnitude and their unit for complete description are called vectors. Let's say you are saying that this is the coordinate of your home, and you are moving along this path to reach your school. So distance is the length of the path. It is a scalar quantity since it does not depend upon the direction in which I am going. But displacement means distance covered in a direction. So displacement is not the length of this path along which you are going from your home to school, but the length of the shortest path. This line represents the length of the shortest path. Between 2 points. Since it is dependent upon the direction. Why it is dependent upon direction? See, I am mentioning here length of shortest path between 2 points. So if I say that this is point A and this is point B, then our direction here is from A to B. This is the direction here. Since we need to mention direction while describing these types of physical quantities, we call them vectors or vector quantity. Fine. Okay. The next thing that we are going to learn about is called the representation of vectors. So a vector quantity is represented by a straight line with an arrow at one of its ends. Okay, so for example, we can represent a vector like this, where this point right over here is what we call the initial point or the tail of the vector. And this is known as the terminal point or head of the vector. Okay, so say it has a direction. If we mention that this is A and this is B, then we represent it as vector AB. And to write it, we represent it as a arrow mark at the top. See, this arrow mark is not actually dependent upon the actual direction of AB. So we are not going to use this if AB is like this. No, we are not going to do that. It's a wrong representation. And whereas this is a right representation. Mathematical. These are mathematical representations. So we can write AB as, let us say that this represents the displacement of a body from point A to point B in the direction from A to B. So we can say that the body has moved a distance of AB, length of AB, in the direction of east, or we can also say in the direction of, or we can also write it as towards B. Since it is going towards B, we can write it like this. What is meant by this term? This is called the absolute function. It represents the numerical part only of any vector, right? It represents the numerical part only of any type of vector. Okay. So if I consider velocity, velocity is basically the speed in a particular direction. It can be referred to as the displacement covered in a certain time. So if I'm considering this same example, that a body is moving from A to B. So what we can do here is we can, let's say, if we want to represent its velocity, let us say we represent it as V. It is just a variable. You can consider other variables, but to represent a velocity by its initial letter V is a common and conventional practice, which means you normally use this notation to represent vectors other than any other notation. Although if you mention that this is equal to the velocity of the body, then it is not wrong, right? You can also use A, B, C, D, whatever you like. Okay, so you can say that V is in the direction of AB. Which is same as towards east in the previous example. Okay, so now what we are going to discuss is about equal vectors. Two vectors are said to be equal when they are equal in magnitude and parallel in direction. Are said to be equal if they are equal in magnitude and parallel in direction. Okay, so let me give you a very small example like this. This is a vector. Let's say this. I can name a vector with using a single letter also. For example, like this A. Okay, I can represent it is like represent this vector like this also. We take this particular vector right over here, and if we have the same length and if they are parallel to each other, then they are called equal vectors. So if this is another vector B, and if magnitude of A is equal to magnitude of B and direction of A and B are parallel, we can say that A is equal to B. But what if they are just, the magnitude is equal and the direction are anti-parallel. What do I mean by this? Give a heading for the negative of a vector. If two vectors are equal in magnitude and opposite or anti-parallel to each other, then one is said to be the negative of the other, which means, let's say we have a certain vector like this, and we have another vector which is parallel in direction, but in the opposite manner. Like these two lines are parallel and equal in length, but its direction is just opposite, which means it is anti-parallel. Okay. So we can say that if this vector is A, and this vector is minus A. Okay. Okay. So this is the very preliminary concept of vectors and what they mean. Their significance can be understood in real life situations like this. Like if you travel from home to your school, you are going in a particular direction which is from home to school. That we represent using vectors. Thank you for the class.